So another type of problem that you might have is that you might have to see an equation worked out, and then you might have to show in the two-column proof that there's a certain solution to this equation. So we're going to say that we have these statements. And we're going to always say that we're going to use a two-column proof. This just helps us set up the statements and the reasons in a pretty organized manner. So we're given that 3x squared plus 2x plus 7 is equal to 2 times x plus 44. We're also given, well, we want to make sure that we're going to prove eventually that, we don't know what step, but we want to prove that x is equal to plus or minus 5. And this just means that we could prove that x is equal to 5 or negative 5. And so we're going to prove actually that both of those values work in this equation. We're going to solve this equation. So this first step that we're given is going to be given, which is kind of our pretty easy first step for any geometric or algebraic proof. Then we're going to just work out this equation. So we have the left side of the equation is going to stay the same because I see some simplification that needs to happen on the right. So we do have this parentheses. We have this x plus 44 quantity. And since it's a sum and it's being multiplied by a constant number, we're going to use the distributive property. So 2x plus 88. 44 times 88. 44 times 2 is 88. So that was the distributive property. And then we can look and see what else we can do here. So we're going to take the x terms here, because we can't combine an x squared and an x, so we want to try to get this x squared by itself. If you subtract 2x off of both sides, that's going to be the subtraction property of equality. That will leave us with 3x squared plus 7 is equal to 88. So then this actually is 2x plus negative 2x equals 0. That cancels out, so that's going to be the inverse property. Then we can subtract 7 from both sides because of the subtraction property of equality again. Then we bring down 3x squared equals 88 minus 7, which is 75. And then we can also say, if you really wanted to, we can also make sure that we say and substitution. Actually, not there. Not there, not there. It's actually here. Not only are we using the inverse property here, because 7 plus negative 7 is equal to 0, but we are also using substitution, which I feel like is worth mentioning. So 88 minus 7 can be substituted for 75, but I will actually be taking inverse as the correct answer there. So then we'll do the next step of the equation, which allows us to divide on both sides. Division property of equality. And then we have x squared is equal to 25, which is 3 divided by 3 is equal to 1. So we're technically using inverse there. But we're also using substitution again. 75 divided by 3 is 25. All right, so now we're doing the, I guess there's technically 2 more steps we could squeeze in. So 9, we could say that we're taking the square root of both sides of an equation. 25. So that is the square root property of equality. That's really not one of our properties, and it's a little weird, but it's definitely something that we're allowed to do. If you had to fill in the blanks here, this would already be filled in for you. There would be some other ones missing that are a little bit more obvious, just heads up. So when you take the square root of any whole number, you have to also be careful, because if you want to just say that this is 5, it's not just 5, it's positive 5 and negative 5, because you have to remember that negative 5 times negative 5 equals 25, and 5 times 5 equals 25. And the definition of a perfect square is to say that each factor that's repeated is the square root of that perfect square. So 5 is the square root of 25 and negative 5 is the square root of 25. So that's why we put it there like this. And the reason we know that is just because of the definition of square root. And we have achieved the final step. So we were told to prove that x is equal to plus or minus 5. So therefore we know that we're done, and we've done everything in accordance with the deductive reasoning. We followed step by step. So we're done.